Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
Welcome to the Computer Chronicles. I'm Stuart Chaffee. Gary Kildall is in Japan this week on assignment, and sitting in is Herb Lechner of SRI. Herb, our subject this week is utilities, and I don't mean the gas company or the electric company, and I don't even mean information utilities. I'm talking about that special kind of software that's used by programmers or even end users to debug or solve other kinds of housekeeping functions inside the computer. You know, many people who use computers quite a bit really don't know very much about utilities. Is there an easy way to define what a utility is or does?
I think it's another one of those terms in this rapidly evolving field of computing that is not precisely defined, Stuart, but I think that most people would agree that, as you pretty much have said, utility programs are those programs that help us do some of the routine housekeeping functions that otherwise would occupy a lot of our time and energy. Let's see what our guests define as being utility programs.
Okay, we're going to take a look at some interesting utilities with some exotic names like Turbo Pascal, Animator, ProKey, and DiskLook. But first, let's get some more background on utilities.
The personal computer's popularity is due in large part to its enormous flexibility and friendly operation. For most PC owners, the machine is a means to speed up work tasks by providing more powerful tools to perform them with. Programming utilities are the software tools that can increase the flexibility of the machine itself. Utility functions will copy disks, reorder programs, translate languages, and even help retrieve material from a crashed disk. For a programmer, debuggers help to uncover software problems by providing breakpoints for examining the construction of a program. Once the problem is determined, debugging suppressors can find and correct the error every time it repeats. Assemblers and compilers are the translators of programming languages. Whether a program is written in assembly code or in a high-level language, it depends on a translating utility to interpret it into machine code. Reflecting the explosion of hardware accessories for PCs, utility programs have become important software accessories, the interactive windows that permit a user or programmer a closer look at the heart of the machine.
To computers, utilities are indistinguishable from application programs. Utilities save programmers time, make software applications faster or easier to use, and perform some maintenance functions which the operating system does not provide. Programs which sort data efficiently, print data in a variety of formats, copy files or disks, and display data graphically are good examples of utility programs. Software developers and computer manufacturers often provide utility programs for use with their computers or programs. Often, hobbyists share or market the utilities they have written, which perform functions needed by others. The sale of software utilities and other application packages is becoming big business, paced by many personal computer users who can't or prefer not to do their own programming. Additionally, as utility programs become friendlier and easier to use, they become more acceptable to users and bring commercial success to their creators. We'll talk more about do-it-yourself application development later in the lesson. In the next program segment, we'll see two utilities used by programmers to speed up the program development process. Then some utilities for end users will be demonstrated. So let's get back to our program.
Joining us now is Philippe Kahn, president of Borland International, and Peter Norton, president of Norton Utilities and the author of 2 new books on the PC Junior from Microsoft Press. Herb?
Peter, you've written some utility programs. Could you tell us and the audience, please, how do you define a utility program?
The simplest way to understand what utilities are is to think of them as tools, like screwdrivers, wrenches, things like that. They help people use their computers. Utilities sort of fit into an intermediate category between operating systems that make the computer go and end-user programs like a word processor that do something very specific. Utilities kind of fit in the middle. They can be professionals' tools, they can be home users' tools, but they're tools. They help you do little things with a computer.
Philippe, Peter mentions they can be home user tools or professional tools. One thinks of utilities as kind of programmers' tools. How is there an end-user application here?
An end-user application to tools? Well, if you ever used a computer, for example, and you've deleted accidentally some files and you wanted to recover them, you'd find an application to that. Now, there's also a lot of other tools, things that your operating system can't do on your computer and you would like it to do. And maybe you yourself, if you're programming a little bit, even in BASIC, have developed your own tools to do certain things. So now some companies do deliver some tools. Also tools for people professionals who develop software and need some more sophisticated pieces of machinery that go as a complement to compilers and things like that.
Do you consider compilers to be utility programs?
Well, the compiler, Peter mentioned wrenches and things like that. The compiler is the car factory, and the tool is the garage or something like that, you know, where you fix the car or something like that. Compiler is really where you develop the software.
I see.
Okay, you have here something called Turbo Pascal, and tell us what that is, Philippe.
Turbo Pascal is a one-pass native code compiler for Pascal, which is our implementation of Pascal. It's extremely fast, oriented both towards the professional user and the student. For example, let's compile a little program I have here. So if I type C to compile, it says compiling 16 lines, error 1, press escape. So usually when I'm using a normal compiler, I get an error, I have to call my editor, call back the compiler, and so on. In this case, I just press escape. And here I find out that error 1 was forgetting a semicolon. So here I'll do this, insert a semicolon.
Now, how did you know that was the error, Philippe? Just because it pointed you to that portion
exactly,
of the code.
Yes. And I could extend my error messages to say semicolon expected. It's just I didn't set it up this way. So now we will compile, and we just compiled successfully. What we just did that took a second to turbo would take somewhere between 20 seconds and a minute to any other compiler by the time you compile, et cetera, et cetera. So now let's try to run the program. So we'll type R to run, and it asks me for a number. So I answer 12, and it'll tell me that it performed 12 tests. It asks me now if I want to continue. Let's say yes. And it asks me for another number. So now my Pascal program is expecting an integer variable, and I will, by accident, feed it a character. Now this is in Pascal what is called a type mismatch. And any other compiler at runtime like that would just abort, say IO error, and would abort unless the user has the programmer has taken the necessary measures to avoid those
Okay, what does Turbo do?
So if I press return, Turbo says IO error, like any other one, program counter, whatever, program aborted. And then searching, 13 lines, runtime error, position found, press escape. Now when I press escape, the cursor is right where the runtime error occurred. It ran number, which is an integer variable, and actually we fed it a character.
Okay, well, I'm going to forsake you gentlemen right now to talk to Joanne Cannell from Micro Focus, and we're going to talk about a program called Animator that works with COBOL.
Great.
This is Joanne Cannell with the technical support staff at Micro Focus, and Joanne, you have something called Animator here, and tell me what kind of utility is Animator?
Animator is a visual debugging tool for COBOL programmers. It lets the programmer actually see the source code and run the program and manipulate the code and actually watch the program as it executes.
Okay, if you didn't have something like Animator, how would you accomplish the same kind of debugging?
Well, in maintenance, if you inherit somebody else's program and you want to make a change, you have to be able to understand the program. And to do that, you would try to find a current listing, if there is one, or get one printed out, wait for that, and then sit down with the listing and play computer by starting with the top of the program and trying to follow the logic through and trying to keep track of values and sticking your finger in the listing and following it through. And after a while, you just lose track of where you're at. But
okay, show me how Animator does that.
Well, with Animator, you can let the program execute right in front of you. You can do there's a sub-menu, and you can set breakpoints, you can display values, you can execute the program, you can find values. There's a whole sub-menu of things you can do.
Okay, what program do we have in here that we're debugging?
This is the Aristophanes Sieve program, and it was a program written by Byte Magazine. It calculates and displays prime numbers.
Okay.
And in order to execute a statement, you hit the E for execute, and it gives you a sub-menu. And you can execute a single step by hitting X. So far, it's just displayed space upon the user screen. If I execute the next two lines, I can just hit an X, and it's moved a 101 to curs, which is a special name for cursor position, and displayed start of routine at curs. You're still seeing the source code, but to see that, you can hit U for user, and it'll show you the user screen.
Okay, so you're looking both at the user's output of what's happening and looking inside the program as it's running instruction by
Right.
instruction.
When you're running in this mode, when you're running single step or in the Go mode, which I'll show you in a minute, you can run single step and you can just stay on the source code and switch back and forth. When it gets to accepting a value, if it's requiring input, it would switch to the user screen automatically. Other things you can do is you can reset execution at another point. But first I'll show you, you can display values, say, curs, by just typing in the name with the D command. It'll show you the value is 0101. And I can change that value by typing in, say, 1205, and that would be the 12th line, 5th position. I can reset execution by moving the cursor back up to a line I want to re-execute and doing a P for program counter and an R for reset. And then if I hit X, I'll re-execute the line. So I should see start of routine somewhere over here. And if I look at the user screen, you'll see that. So you can see that I have control of looking at both the source code and the user screen, displaying values and restarting execution at another point.
What was the Go function you mentioned?
The Go is a whole submenu under the execute. If I go into Go mode, it'll execute at a speed of 5. And so you can just let the program run and watch the cursor move, and you can control the speed to see what you're comfortable with. Right now it's 5. I can speed it up to 9, and it's executing very quickly through this little loop, or I could slow it down to, say, 2, and it'll execute more slowly. It's whatever you're comfortable with.
Okay, briefly, Joanne, how would someone use this? Is this really for programmers only, this kind of a tool?
It could be used as a learning tool for COBOL. It's a really helpful tool for both maintenance and debugging in the programming world, but it could also be used as a tool to understand what a program does, because you can really watch the program as it runs.
When you say maintenance, that's kind of a term of art in the programming world. What do you mean by maintenance?
Well, that's where you have, there's a whole stack, there's something like 2/3 of the programs that are out there in the business world are maintenance, are programs that are already in existence and need to be maintained. That's what most of the programming is. And in order to maintain a program, you need to understand what it's doing. And to understand what somebody else's program does, you can use a tool like this to actually see what the program is doing.
Okay, thanks. That's fascinating. Okay, in just a minute, we're going to take a look at a new utility for the IBM PC that lets you take the keys on your keyboard and turn them into, well, just about anything you want. That's coming up next.
The application development process is one that has seen some changes over the past 30 years, but hasn't improved with the pace of hardware. In the early years, application development required a great deal of computer expertise. And, as we have previously discussed, it required programming in machine language, a very time-consuming and error-prone process. And still today, it is a process of precise definition of user needs, algorithms which cover all possible data and logic conditions, and detailed computer programming. Computer application systems can be very large and complex. Therefore, it is necessary to prepare and plan the development process carefully. There are 7 steps traditionally followed in developing a computer application. The first is a feasibility study to assess the practicality of computerizing the problem. The second step requires a detailed statement of user requirements for the system. The third step calls for the detailed design of the internal architecture of the system. In step 4, the development plans are made. These include schedules, staffing and specifications for programming, documenting, testing, and training. And in step 5, those development activities are carried out. The lines of code are written, the manuals are written, the program is tested and debugged, and a support staff is established. Step 6 is the actual implementation and operational cutover of the new system. And step 7 is the continuing maintenance and modification of the application system over its life cycle. There are other approaches to application development than the traditional one just discussed. Prototyping is a more evolutionary approach in which a system is developed to meet the limited needs of a few users. Prototyping is advantageous in getting a limited computer application running sooner, but may not produce the more comprehensive system as quickly as the traditional development approach. Distributed development, which is described in the text, involves the centralized control and regulation of applications and data shared by computers in an office or a plant site. The guests in the next video segment demonstrate some interesting utilities designed for the personal computer user. Let's get back to the program.
Joining us now is David Rose, Director of Product Planning for Rosoft. David, you have a product called a utility called ProKey. Tell us what ProKey does.
Well, ProKey is a software accelerator, software customizer. When people get microcomputers and begin to buy off-the-shelf software, they find that the software does kind of 99% of what they want, maybe 95%, but not everything that they want. It was written by a stranger in San Mateo or something. And they're not doing general purpose things with it. They have specific things that they want to do for their business or for their profession. The software doesn't do that. So they need to customize that software, take the blemishes off of it, and fix it up so that it does exactly what they want it to do.
Okay,
or they
so
want...
This is an end user's utility then, as opposed to a programmer's
Definitely.
utility.
It's for everyone who uses a computer.
And you have an example you're going to show us on how this helps WordStar.
Right. We've loaded some text into WordStar so that we have something to play with. What we're going to do is try to move a sentence. Now, WordStar itself doesn't know how to move a sentence, so we have to teach it how. The funny thing is, it never learns how. No matter how often you teach it, it never learns how to do that. So we have to do a Control-KB up at the front of the sentence, move to the end of the sentence, do a Control-KK, which is its other command for marking a block of text. Now it has reduced the brilliance of that sentence to indicate that it has been marked. We move up to where we want it to go to.
Okay, just to make it clear, David, you're not showing us ProKey yet. You're showing us WordStar
This
right
is
now.
how
That's
WordStar
right.
would do it.
This is how you'd have to do
Okay.
it with WordStar. So now we do a Control-KV, which is WordStar's command to move something. So you see the sentence is moved. Now we have to reform this paragraph because it's had a sentence inserted into it. That's a Control-B. Now that one looks pretty good. And then we have to do a Control-B on that paragraph because it lost the sentence and so it had a hole in it. And then we have to kind of bring this sentence back from being dim so that we're all set to go. So that was a lot of thinking we had to do about the details of moving the sentence, not about what we were trying to communicate to somebody in the article that we're writing.
How does that work with ProKey, David?
Well, with ProKey, you can just do it with one single stroke command, in this case an Alt-S. That will just mark the entire sentence. ProKey knows how to tell WordStar how to find the beginning and end of the sentence. Then you move up to where you want to move the sentence to, and another single keystroke will move the sentence. Also, in this case, ProKey knows how to tell WordStar to reform both of the paragraphs. So everything has been done now, and we've thought more about what we were doing instead of how we were doing it.
Okay, we want to get to Peter, and maybe, Herb, you can help load Peter's software here. And meanwhile, David, I want to ask you a question. In addition to WordStar, what other kind of goodies can ProKey add to a VisiCalc or a Lotus, for example?
Well, first thing that you can do with ProKey is remove the blemishes from these products. They have funny characteristics about them. Each one of them has a little problem here or there. It's just not built right for the end user, for the specific purposes of an end user. So you can fix them up in these little areas where they're not quite right. The other thing is that you can store knowledge of one person for use by another person, so that one person learns how to build a particular spreadsheet, how to use that. They can automate that into an entire script for other people to use without having very much training.
Okay, Peter, you have a whole package there called Peter Norton Utilities, and what do they do?
Right. They do an awful lot of things because they're a toolkit, but there's two things I'd especially like to show you because they're very interesting and very useful. The first one we want to look at is called Disk Look, and it lets you explore what's on your diskettes. The screen here shows the menu of Disk Look, the selection of all the things you can do with it. For example, if you want to see what some particular file is like, you can have it look at the whole diskette, and down at the bottom of the screen in that grid, you'll see a map of the breadth and width of a diskette, all the space that's there, and it shows where a particular file is located on it, and also gives a lot of interesting information about that particular file, its size and when it was created and so forth. We can look at other files, like we see one here in green with the diamonds on it, and we see what date it was created and so forth.
Okay, what we're seeing then, literally here, Peter, is a map of the disk and what's where on the disk.
Right. In this case, we're seeing one particular file on the disk. If we want to see the entire diskette, we can ask to have all the files gathered together and get the same kind of map, but for everything. This map happens to turn out to be interesting because it shows a hole in the middle. It's an unused portion of the diskette. That's the brown area between the two green areas. The green areas are in use with our information. And very interesting on this particular disk is a little danger area that we see in the lower right hand that's flashing bees. When a diskette is set up, it turns out there can be unusable parts on it, and a sort of a fence is put around that to make it safe. And this program happens to show you where those danger areas are, just so you can know about them.
So they are the bad parts of the disk,
Right.
which is that sliding up.
There's lots of other exploration we can do, exploration we can do on a disk, but that gives you an idea of the kind of snooping around you can do with a disk exploration utility.
Okay, now one of the best tricks you have is this file recovery thing where you
Right.
can recover a file you thought you deleted.
Right.
Show me how you do that.
People have valuable information on their diskettes, and by accident they can delete them, kill them, erase them. Now it turns out that when you do that, they don't actually disappear from the disk, they're just unusable. It's like taking a file folder out of a filing cabinet and throwing it in the trash. If the trash hasn't been hauled out, you could grab those pages and put them back in the file folder. And that's what my unerase program does. Technically it's complicated, conceptually it's simple. We just go in and grab what was there and say, I want it back.
Okay, show me.
Sure. In this case, we ask it to show us all the stuff that's been removed. The names of the files have been removed. We pick the particular one that we want, and unerase tells us what there is to know about it, how big it is, so how much information we could look for. Then we tell it to go hunting for the first part of our file. I happen to recognize this. That's the letter I was writing. That's the information I want to recover, so we tell unerase to bring it back. Then we ask it to bring back some more. I recognize that as my information, so I say, okay, take that. At this point, I might want to review what I've recovered. Have I got everything? Have I gotten some extraneous information? So I can go through, review my information. Looks like exactly what I wanted. So if everything's okay, I tell it to save the information, and that file's back there. Whatever I've written has been miraculously brought back, and maybe hours of work saved.
Okay, so what you were doing there was searching the disk to find out whatever it was there that you recognized as the stuff you had deleted or
Right.
killed. And explain again what's going on. When I kill a file, I'm not really eliminating that material, am I?
No, you're telling the operating system to throw it away, to move it from where the work is going on, the useful portion of the disk, to just put it in the trash pile. Now, if that trash pile hasn't been emptied or the space on the disk hasn't been reused, then you can go in and actually find the information that you had there in the first place.
Where do you get the idea for what would be a good utility program to develop for people?
In my case, and I think a lot of people who create utilities, you start off using the computer, you find you need something, you create a utility program for your own use, and then you realize that the rest of the world could use it too.
You've got, in fact, some other utilities on your disk other than just the ones we looked at. What other
Right.
kinds of tricks do you have in your bag there?
Well, it's quite a bag of tricks. There's 20 programs in all, so it's a lot to explain. But about 5 of them do different kinds of file recovery, different specialized purposes, and there's a good explanation of when to use which one. The one we saw was when I said, throw something away, and then realized I didn't mean to do that. There's other ones for when there's physical damage to the diskette. your son spread peanut butter on it, and you've got to get back what you can. There's other ones that help you keep track of how long you were working on the computer, that actually calculate how long things were running for, and lots more too.
Okay, gentlemen, that's fascinating. Thanks so much for being here. Thank you for joining us on this edition of the Computer Chronicles.
Traditional application development has generally applied to larger computer systems. With the proliferation of mini and microcomputers in recent years, a problem has arisen. The need for the careful development of applications, which is imperative on a mainframe system that may serve hundreds of users throughout an organization, runs counter to the speed and flexibility of application development on the smaller systems for one or a limited number of users. On the other hand, these small systems, applications, and data files developed by programmers and user programmers are incompatible. These subsystems often don't communicate with each other or with the larger systems. The organization or business may thus lose the opportunity to centrally integrate those systems and integrate and control the flow of data throughout the organization. This is fundamentally a classic organizational problem between macro and micro optimization, between central and decentral control, and between scale economies and more rapid response. However, since the problem is shrouded in the mystique of computerese, it frequently does not get resolved until a lot of organizational stress and mistakes have occurred. The resolution of the application development problem lies in clear-headed management decisions and controls. Some applications involve only local data and should be decentrally developed. Some applications may be decentrally developed but should conform to enforced data interchange standards. As we've mentioned, some applications can be prototyped. Finally, some applications should be centrally developed and controlled to meet the needs of many users. The policy decisions are generally pretty obvious if addressed knowledgeably and unemotionally. Our next lesson covers databases. Be sure and read Chapter 9 in your text, and I'll see you then. I'm Herb Lechner.
Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.